Hello guys, welcome to chapter 5. We're gonna be talking about chirality, right? So we're gonna go over question 36, right? This question looks like a lot. You get the question and you're like, wow, there's a lot of words, there's a big structure, is it hard? It's not hard, it's easy. We just have to go over a lot of concepts that we have to review. One of them is chiral centers, right? Before even we go into chirality or everything, I think it's easier to explain what a chiral center is. So let's imagine this one is an iodine, this one is a fluorine, this one is chlorine, right? And this one is a hydrogen. They are different molecules, you see? X, Y, D, A. A chiral center is a carbon that's connected to 4 different molecules, right? But do they have to be different molecules? No. This one is a C3, because you have 3 carbons, and you have 6 hydrogens. Let's say this is a bromine, this is a chlorine, right? Do you have a chiral center? So now let's look at this one. Let's look at the first carbon, right? It's connected to 3 hydrogens. So the hydrogens are the same, so no chiral center. We look at the second one. It's connected to 2 hydrogens, which is already bad. But if you look to the right, it's like this one is different and this one, but it's connected to 2 hydrogens, which makes it achiral. And when we look at this one, we have 1 chlorine, 1 bromine, right? 1 hydrogen, and we have 2 carbons. It's connected to like molecule, right? But it's different in the way they have like a different structure, right? Maybe if we change this one from another, like, just imagine this is a random molecule. Now this will be like a chiral center because the right and the left, both of them are different. Like, even though they're attached to a carbon, if you continue the bonds, they're different. Okay, too much yada yada. So let's go to chirality, right? What's chirality? Well, the textbook definition of chirality is describe the symmetry. What's a symmetry? Like my face. Okay, no. A symmetry is, let's see, this, if you cut it in half, this will be symmetrical, right? But if you do this, and you cut it in half now, that's asymmetrical, right? So, describes a symmetry where the enantiomers, what's an enantiomer? Give me a second, bro. Cannot be superimposed. What superimposed means? Okay, so an enantiomer is a mirror image. Mirror image of something. Let's see. Let me do something really quick. So I have these, and I have this, right? So when you look yourself in the mirror, right, it's gonna come reflected the stuff that's in the front. So this will be a mirror image of this, right? That's a mirror image. So an enantiomer is a mirror image of each other. They cannot be superimposed. Meaning, well, here we go. There's some molecules, right? This will be C5, Cl, Dr, H6, H6, so 6 plus 3, it's 9, H10, right? Both of them are the same, their bonds, they are connected in the same way, right? But the way they are arranged in, like the way they are arranged in space, like, I have an idea. So Jesus, what was that? What's all that tomfoolery? I didn't sign up for this. Okay, that was the best way of explaining. You saw all those Jesuses. I bet you did. So you saw all those Jesuses, but all of them were me. They're the same me, like same clothes, same person, right? Like I was not wearing like my headphones. I was not wearing anything. It was same person, just different spatial arrangements, right? So. But looking back to the mirror images, these two are mirror images of each other. If I arrange them, they will. So now, Now they are. They are mirror images of each other, right? So whenever you look at them, if you're looking at them from a mirror, you're looking at them from a mirror. But you say they are not superimposable. What does that mean? It means that it doesn't matter how much you flip them, you can put it on top of each other and they will be the same. If I try to put it on top, this one will be red and green. This one is green and red. Now I flip it to this side. What? This one is green and red. What if it doesn't matter. They cannot be superimposed together. It really doesn't matter what you do. So, chirality center. So we go back again. So we look at our molecule and we'll be like, well, so for this molecule to be chiral, like you say, to have an enantiomer, there will be a chirality center in the molecule. And I must say, my friend, you're really smart, because there is. So we look at a hydrogen, okay. We see this was a bromine or a chlorine, I remember. Methyl group, monkey eats bananas. No, monkey eats bananas, yeah. A propyl group with methyl, no, what we say, this was not metal, this is metal. This is either a bromine or a chlorine, right? So it's 4 different molecules. So the mirror image is gonna be chiral. The mirror image is gonna be chiral because you have a chiral center. So now we have to identify this kind of lesson over here, right? Because I just wanna keep a little bit, you know. So we see a double bond. But what happens when we see a double bond? That the carbon cannot be attached to 4 things anymore, because now that double bond is taking the spaces where the carbon will be attaching, right? They're taking it to make a double bond with oxygen, right? So a double bond is a red flag for a chiral center. So, man, this is how a double bond will look in the model kit, right? So we get to the first one, and we are like, this is not, so the mod, it's not, right? So we can go to the right, we go to the next carbon, right? So this carbon is attached to a methyl group. You're gonna have a hydrogen here, right? This implies that you have an oxygen and you have another carbon. So this is a chiral center. So this carbon attached to 3 hydrogens. So it's gonna be a no-go. Okay. So now we go for the next ones, right? So we go for this one. So you have 1, 2 hydrogens. Because it implies because carbon makes 4 bonds. So this one is a no. So metal group, looking like you have an OH. Looking this, you have a metal group, and you have a different, and you have an OH. So this one is a chiral center, right? Chiral centers. So we can put a check mark on it. Go to the next one. You're gonna have a hydrogen implied here. OH. Different. Go to your check mark, right? So we come here. Next carbon, right? And we are like, okay, you have an implied. So we have an implied hydrogen, right? So we're gonna go down. It's different. Well, these two, they're connected. It could be. No, because if you keep going down the line, it's not gonna be the same things. See connectivity to the right, to the left. You're gonna have all this stuff and all this stuff, right? So that's why they're different. And a metal group. So I do a little checkpoint in the chirality center. Okay. We have a metal now, right? Let's go. So we come to the next carbon. This is an alcohol. Remember I talked about it? I hope you do. Right, left. Implied hydrogen. Check mark. Right, left. Black hydrogen, check mark. Double bond. You remember I told you cannot have double bonds? One. Is this an oxygen? Dun dun dun. So, like, implied hydrogen, right? Different. A little check mark. Two hydrogens. That means implied hydrogens, right? No chirality. No chiral center, yes, chirality. Black hydrogen, CH2, check mark, no, check mark. So, this was everything for today, guys. I hope you liked the video. If you think there's anything I went over, you can tell me in the comments. If there's any specific problems you would like me to go over, you can tell me in the comments. Any specific videos, any requests. Somebody told me I should change the animal to a dog. Somebody I should buy a microphone. It's in its way. I hope it's a good quality. If you don't see me with a microphone, it's one of those clip ones. If you don't see me with a microphone next video, it's because, well, maybe I'll make another video tonight. But if you don't see me with a microphone, like in chapter 13 or in more chapters, it's because the microphone was not good quality.